All right, this one is a question where we're given a whole bunch of roots to a characteristic equation, and it's really just testing whether or not you know how to deal with repeated roots or roots that are linearly dependent on each other. So the first thing that I like to do here is check to see how many roots I have, just to make sure I have the right number of c's. So 1, 2, 3, 4, 5, 6, 7. This is 8, 9 because it's plus or minus 2i. Plus I is one of them. Negative 2i is another one. 10, 11. This one is 4 plus 7i. That's one of them. 4 minus 7i is another. So that's 12, 13. And the next one is 14 and 15. So at the end, I should have 15 C's. All right. So the first one is going to give me C1 e to the 2t. This would be x equals x of t. Next one is going to give me plus c, and I'll cross them out as we go. C2 e to the 3t. Next one, the zeros. I've talked about this in an earlier video, but when I have e to the 0t, it gives me 1. So that gives me plus C3. And then I get plus C4, but this is where we start getting the linear dependence thing. I can't have a plus C4 and just leave it like that, because it could be combined with this C3 right here into a different C. And then I wouldn't have enough C's for how many times I've integrated. So I get plus C4 times T. That's this one. Plus C5. Same reason here I do T, but then I got to bump it one more. That gives me T squared. Plus C6 times e to the 6t. Plus C7 e to the 2t. Now, look, that one got snuck in there. This one is linearly dependent on that one. So I need to do a C7t e to the 2t, because otherwise it could be combined with that one. Now, plus or minus 2i. You should know that that gives me plus C8 cosine of 2t plus C9 sine of 2t plus, okay, so we did that and we did this. All right, now we got some linear dependence going on here again. We have repeated roots. So I get plus C10. I want to do a cosine of 2t, but it needs to be linearly independent, so I put a t on it, plus C11 times t times sine of 10t. Why did I say 10? Sine of 2t plus, so I got that. All right, here we go. The 4. The 4 is the real component. That becomes the exponential piece. So I get, or the real exponential piece, e to the 4t, open parentheses. Don't forget your c. It goes here. It's c, not 11, c12. And then I have a cosine of the imaginary part there is a 7, so I get a 7t, plus c13, sine of the same thing, 7t, plus the last term is a repeated root of that, right? So I'm going to get a t times e to the 4t, open parentheses, and then the same thing I had there, but now I've got a c14 cosine of 7t plus c15 sine of 7t, close. Done. What do I want to check? I want to check that I have the right number of C's. I want to double check that all of my roots are good. And to me, it looks like these are good. I want to also check that I tacked T's on to the appropriate places. And to me, it looks like this is good. So let's bump on to the next one.